Welcome to aminacademy.com. In strength of materials, let us discuss about columns and struts, some introduction. Columns are defined as long, slender member load axially in compression and having lateral dimension very small as compared to their length. Basically, columns are withstanding compressive loads. A vertical compression member is called a column. If load passes through the longitudinal axis coinciding with the CG of the column, it is called the axially loaded column. Here, this is the axially loaded column. Otherwise, eccentrically loaded columns. Columns are the building structures connected to different footings to transfer the load of the building to the footings of the building. The inclined and horizontal component of the truss are known as struts. Here, these are struts. The cross-sectional area of the struts can be circular, I-sectional, T-sectional, channel, compound, and tubular. These cross-sectional areas can be easily found in the market. Strut, these are the strut members. The slenderness ratio of the strut is mostly found to be more than 20. The slenderness ratio may be defined as the ratio of the effective length of the column to the least radius of gyration. Therefore, when L is the effective length and R is the radius of gyration, then mathematically 1 by R is the slenderness ratio. Difference between column and strut. Column, it is the vertical member subjected to the axial compressive load. The strut, it is the inclined member subjected to the axial load. Column, it is designed to take up the compressive load only. Columns are subjected to compressive load, but strut is designed to take up both compressive as well as tensile loads. Column is generally supported by fixed supports at both ends, that is ground and ceilings. But strut is supported by a hinged or pinch joint at both ends. Like here, it's supported, connected with hinge or welded joints. Column is generally fails by buckling. Strut is generally fails by crushing. The slenderness ratio is more for column. The slenderness ratio is less. Further discuss about column and strut. There are three modes of failure of concrete columns, compression members. That is, a column is in failure in three cases. The failure due to pure compression, combined compression, and elastic instability. These modes of failure is concrete compression members are discussed. Reinforced concrete column is a compression members and transfers the loads from structure to the ground through foundations. These are three types of concrete columns based on the height and lateral dimensions. Long columns are those whose ratio of height to least lateral dimension is more than 12. Is a long column. That is length by radius is more than 12. When the height of the least lateral dimension is less than 3 is called pedestal, and it is between 3 and 12. It is called as a short column. The load carrying capacity and modes of failure of a reinforced concrete columns is based on the slenderness ratio. The slenderness ratio is the ratio of the effective length LE and least lateral dimension of the column as per Indian and British standards. But As per American Concrete Institute Code of Practice, the slenderness ratio is defined as the ratio of effective length of the column to its radius of gyration, which is same as used for structural steel designed as per IS codes. Effective length of columns depends on its support conditions at ends. Here, look at this, some failure happens in the concrete column. Different failure modes of concrete columns or compressive members. First, column failure due to pure compression. When reinforced concrete columns are axially loaded, the reinforcement steel and concrete experiences stresses. When the loads are high compared to cross-sectional area of the column, the steel and concrete reach the yielding stress and columns fails without undergoing any lateral deformation. The concrete column is crushed and collapse of the column is due to the material failure. To overcome this, concrete column should have a sufficient cross-sectional area so that the stress is under the specified limit. This type of failure is generally seen in case of pedestals whose height to least lateral dimension is less than 3 and does not experience bending due to axial loads. Second case, column failure due to combined compression and failure. Short columns are commonly subjected to axial loads, lateral loads and moments. Short columns under the action of lateral loads and moments undergo lateral deflection and bending. Long columns undergo lateral deflection and bending even when they are only axial loads. Even if only the axial load is applied, some bending happens because of the more height. Under such circumstances, when the stress in steel and concrete reach their yield stress, material failure happens and RCC columns fails. This type of failure is called combined compression and bending failure. Column failure due to elastic instability. Long columns are very slender. Its effective length to least lateral dimension is more than 12. Under such conditions, the load carrying capacity of reinforced concrete column reduces drastically for given cross-sectional area and percentage of reinforcement steel. When such type of concrete columns are subjected to even small loads, they tend to become unstable and buckle to any side. So the reinforcement steel and concrete in such cases reach their yield stress even for small loads and fail due to lateral elastic buckling. This type of failure is unacceptable in practical concrete constructions. Code prevents usage of such long columns for slenderness ratio greater than 30. Now, so far we discussed about what is column and strut and their difference and slenderness ratio and failure of columns due to axial bending and other loads. We have done. Please subscribe our YouTube channel.